Hello everyone. As all of you know, due to COVID-19 virus, Government of Punjab has suspended all the teaching activities in his schools and colleges. So our college, Mata Sahib Kaur Girls College Talwandi Sabo, has decided to provide the online classes to all her students. In this regard, today I am teaching the students of B.SC-II. The topic of my presentation is Zeeman effect. This topic is very useful for the students of B.SC, and even in MSc Physics course you will get a question from this topic. So let us begin with the topic Zeeman effect. Basically, the Zeeman effect is the splitting of spectral line whenever an atom is placed in the magnetic field. First of all, I would like to highlight the objectives of this topic, that what student will learn after studying this topic. The first objective is the student will know the reason behind the splitting of the spectral lines. Second point is very important. You must get a question based upon this. Student will able to draw the Zeeman pattern of the certain transitions between different energy state. This is a very important point. The third one, student will come up will understand the normal and anomalous Zeeman effect in detail. And the last thing is the application part. The application part is not being included because presently this is not in our curriculum. In 1896, Zeeman observed that spectral lines emitted by atoms placed in magnetic field broaden and appears to split. So the splitting of the energy levels or spectral lines of a substance placed in magnetic field is called a Zeeman effect. I will explain this again in Punjabi language. Zeeman effects बच्चों की हुंदा है ਜਦੋਂ ਆਪਾਂ ਕਿਸੇ ਐਟਮ ਨੂੰ एक्सटर्नल मैग्नेटिक फील्ड च रखते हैं ਤਾਂ ਉਹਦੀਆਂ ਜਿਹੜੀਆਂ એનર્ਜੀ ਲੈਵਲਸ ਹੈ ਨਾ, ਜਾਂ ਆਪਾਂ ਕਹੀਏ ਉਹਦੀਆਂ ਸਪੈਕਟਰਲ ਲਾਈਨਸ ਹੈ, ਉਹਨਾਂ ਦੇ ਵਿੱਚ ਕੀ ਹੈ, ਬ੍ਰੋਡਨਿੰਗ ਹੋ ਜਾਂਦੀ ਹੈ, ਸਪਲਿਟਿੰਗ ਹੋ ਜਾਂਦੀ ਹੈ. ਸੋ ਦਿਸ ਇਜ਼ ਦੀ Zeeman effect. This effect has been divided into two effects. One is the normal Zeeman effect, another one is the anomalous Zeeman effect. In this lecture I am only discussing the normal Zeeman effect. In normal Zeeman effect, in certain atoms what happens, the spectral lines are splitted into three lines. So basically the study of the splitting of energy levels of an atom having only orbital angular momentum L in the external magnetic field and their spin angular momentum S, it is equal to 0. कुछ एक एटम्स देखांगे ਆਪਾਂ ਬੱਚੋ ਜਿਨ੍ਹਾਂ ਦਾ spin angular momentum 0 ਹੋगा and they possess only orbital angular momentum. ਜਦੋਂ ਆਪਾਂ ਇਹਨਾਂ ਐਟਮਸ ਨੂੰ ਮੈਗਨੈਟਿਕ ਫੀਲਡ ਦੇ ਵਿੱਚ ਰੱਖਾਂਗੇ ਤਾਂ ਇਹਨਾਂ ਦੀ ਜਿਹੜੀ ਸਪਲਿਟਿੰਗ ਹੋਣੀ ਹੈ ਸਪੈਕਟਰਲ ਲਾਈਨਸ ਦੀ, ਉਹ ਹੋਣੀ ਹੈ ਆਪਣੇ ਕੋਲੇ 3 ਲਾਈਨਸ ਦੇ ਵਿੱਚ. ਓਕੇ, so basically this is the normal Zeeman effect. I said the spin angular momentum of such atoms is equal to 0. So spin angular momentum ਜਿਹੜਾ ਹੁੰਦਾ ਆਪਣੇ ਕੋਲੇ, that is equal to 0 means it is applicable to atoms having 2 valence electrons, and these 2 electrons must be oriented antiparallel to each other. That means their spins are antiparallel, so net spin becomes 0. Another is the anomalous Zeeman effect. That is a bit complex, that has been discussed in the lecture 2. I had highlighted a few points related to the normal Zeeman effect. These are very important points. First point is this effect agrees with the classical theory. The second point is, as I already explained, it is observed in atoms having S it is equal to 0. The third point is how we calculate the spin of an electron. There is a formula that is a very basic formula. Total spin of an electron is sum of the spin of all the electrons. That means we can take the summation. Fourth point is a very important point again. Now we know that filled shell have no net spin, so only valence electrons will give the spin. So electron, we know that the spin of the electron is half, and it is not possible to obtain S it is equal to 0 from atom with odd number of valence electron. This is a very important point. I will explain again. मान लो किसी एटम कोले ऑड नंबर ऑफ इलेक्ट्रॉन्स है वैलेंस शेल दे विच मान लो 3 इलेक्ट्रॉन है या 5 है या 7 है लेट अस सपोज 3 इलेक्ट्रॉन्स आर देयर हुन ਉਹ ਤਿੰਨਾਂ ਚੋਂ ਜਾਂ ਤਾਂ ਤਿੰਨੋਂ ओरिएंटेड होंगे एक दिशा च या दो इन पैरेलल एक ਉਹਦੇ ऑपोजिट सो नेट स्पिन इन्हां दी प्लस हाफ आनी है या की है हाफ जुड़ जाऊगी या दोवां दी कैंसल होगी थर्ड वन गिव the spin which is not equal to 0. That means we cannot get the spin as it is equal to 0 with the odd number of valence electrons in an atom. Fifth point. Now in even number of electron, whenever we have even number of electrons in the valence shell, then S can that means even number of electrons can produce S it is equal to 0. For example, if we have two valence electrons in an atom, so their spin can be 0 if both the electrons are oriented oppositely, or they can add their spin that become 1. So atoms with S it is equal to 1 does not show this normal effect. It means atoms having two valence electrons show this normal Zeeman effect. Remember this point is a very important. For example, helium, which has two valence electrons, zinc, gallium, then mercury with spin oppositely oriented, that is S it is equal to 0, showed this normal Zeeman effect. The another thing is all ground states of group 2 having NS2 configuration which is equal to or greater than always have S it is equal to 0 as two electrons align with their spin antiparallel. And the last point, we know the magnetic moment of an atom with no spin will be due to the orbital motion only. So here it is mu b, it is due to orbital motion. Let us try to understand the theory of this normal Zeeman effect. For that, consider an atom having angular momentum L only, that means their S is equal to 0, placed in an external magnetic field B0 along z-axis. Let us specify the quantum state of an atom by orbital quantum number L and energy E0. Then the interaction energy between the magnetic moment and a uniform magnetic field is given by delta E. It is equal to minus mu L, that is the magnetic moment due to orbital motion, dot B naught, which is equal to mu L B naught cos theta, where mu L it is equal to minus E over 2m into L, and cos theta it is equal to Lz over L, Z component of L over L, which is equal to ml h cross over L. So if I substitute the value of this cos theta in the here at the place of cos theta and solve, we get this formula where I substituted the value of E h cross over 2m equal to mu b, which is Bohr magnetron. Thus energy is given by E naught plus delta E. So I substituted the value of delta E, which is equal to mu B B naught ml here. So we get E, it is equal to E naught plus mu B B naught ml. Now the quantum number ml has 2l plus 1 values, and its values range from minus L to plus L. For example, if we have L, it is equal to 0, that means mj has 1 value. Okay. Now if ml has 2l plus 1 values, therefore energy can have also 2l plus 1 values, as ml is related with energy. So energy can have 2l plus 1 values. Thus if, now see, I'm taking example, if I substitute L, it is equal to 0 here. So we get 2 into 0, 0 plus 1, 1. It means ml, it is equal to 0. That means ml has only single value, and this value equal to 0. If I choose L, it is equal to 1, for that mj has 2 into 1 plus 1, 3 values, and these values are from minus L to plus L. That means if L is equal to 1, minus 1, 2 plus 1, minus 1, 0 and plus 1. Similarly, for L, it is equal to 2, we get 5 values of ml, starting from minus 2 to plus 2, minus 2, minus 1, 0, plus 1, plus 2. Substitute these values in energy. So if I substitute L, it is equal to 0, and ml, it is equal to 0, E become E naught. And second values, these are L1 and ml 0 plus minus 1, we got E, it is equal to E naught, comma E naught plus minus mu B B naught, yani ki we got 3 values. Similarly for L, it is equal to 2, we got 5 values. Now let us see this splitting of energy levels in magnetic field diagrammatically. I'm choosing the example of L, it is equal to 0 and L, it is equal to 1. I'm just taking the transition between L, it is equal to 1 and 0. Now for L, it is equal to 0, we know that for S spectroscopic terms, let us recapitulate the spectroscopic terms. For S, L, it is equal to 0. For P, L, it is equal to 1. For D, L, it is equal to 2. In the absence of magnetic field, whenever B, it is equal to 0, that means we get a normal spectrum. Whenever magnetic field is non-zero. Now for L, it is equal to 0, we see that ml has 0 value. It possesses only a single value, which is equal to 0. That means there is no splitting of the S. For L, it is equal to 0. Let us check the energy values of P. For L, it is equal to 1. For L, it is equal to 1, ml possesses 3 values, and these are 0 plus minus 1. So this gets splitted up into 3 levels, minus 1, 0, 1. Now let us apply the allowed transitions rule that are known to be the selection rules. So selection of allowed transition, that is very important. These are known to be the selection rules. For that, delta ml should be equal to 0 or plus minus half. Yani ki only those transitions will be allowed. For that, delta ml it is equal to 0 or it is equal to plus minus 1. From this plus 1 to 0, difference is 1, allowed transition. 0 to 0 value, ml0, ml0, 0 minus 0, 0, that is delta ml0, that transition is allowed. Minus 1 ml value and 0 ml value, this difference is minus 1. So this transition is also allowed by the rules. So we get 3 lines in the presence of magnetic field, and its frequencies are given by this formula, these values that we can calculate in the next slide also. Now consider the transitions between the energy level. We will designate one energy level as EI, another one is EF. We can put up the I and F values in the energy equation. So for that we put the super subscripts I's and F on energies and other factors. Take the difference of these two equations, EI minus EF. EI minus EF, it comes out to be equal to E naught I minus E naught F plus mu B B naught MLI minus mu B B naught MLF. EI minus EF, it is equal to H nu. E naught minus E naught F, it is equal to H nu naught. From the last two terms we take mu B B naught common, so this is equal to mu B B naught bracket MLI minus MLF. This MLI minus MLF is delta ML divided by H. We get E is equal to the frequency is equal to nu, it is equal to nu naught plus E H cross over 2m H B naught delta ML. This H cross is H over 2 pi, it means the value of H get cancelled, this 2 become 4 in the next step. So the final frequency is mu naught plus E B naught 4 pi m delta ML. So now selection rule says that this ML is 0. If this ML is 0, then this whole term becomes 0. That means nu become nu naught. That is the first value, central one. For ML plus 1, so we got this value. For ML minus 1, we got a nu minus E B naught over 4 pi m. So basically this is the theory of the normal Zeeman effect. I hope this effect you learn all the theory and concepts behind this normal Zeeman effect. Let us do an exercise for that. The exercise is to draw the Zeeman pattern for the transition D21 to P11. For that, T21 or P11, we must have the knowledge to write the spectroscopic terms. So first of all we learn how to write the spectroscopic terms. Now let us take the example Lj2s plus 1. This J is equal to here 2, okay, and for 2s plus 1 this is the multiplicity which is equal to 1 here. So L is equal to the J is equal to 2 and 2s plus 1 is equal to 1, that gives S it is equal to 0. We know that here if we have S, then L it is equal to 0. If we have P, L it is equal to 1. If we have D at this place, then we get L it is equal to 2. Now here L is D in our case, so for D L it is equal to 2. Similarly for P11 I calculate the value of L, J and S. These are also calculated here also. Now we know the selection rules. D21, the meaning of D21 implies that L is equal to 2, J is equal to 2, S it is equal to 0. P11 implies L is equal to 1, J is equal to 1, S it is equal to 0. Now for P11, L it is equal to 1. we know that if L it is equal to 1, then Mj have 3 values. Formula is 2L plus 1. L 1, that means Mj has 3 values. Range from minus L to plus L, minus 1, 0 and 1. These are written here. Okay. And then for L it is equal to 2. If I use the formula for the number of values for Mj, that is 2L plus 1, I substitute the value of L, it is equal to 2. We got Mj has 5 values, and these are from minus L to plus L, minus 2 to plus 2. That means minus 2, minus 1, 0, plus 1, plus 2. And we also know the selection rules. This is a very important. Selection rules are very important. Those selection between two energy levels will be allowed for the delta ml, it is equal to 0 comma plus minus 1, and delta L is equal to plus minus 1. These type of transitions can be allowed. Rest of the transitions are forbidden. Now let us see these red lines. This is for Mj minus 2. So this transition is from minus Mj value minus 2 to minus 1. That means minus 2 minus of minus 1, that is equal to minus 1. That obeys the selection rules. That means this transition is allowed. Second one, this Mj is equal to minus 1, and this goes to Mj 0. Minus 1 minus 0, Mj is equal to minus 1. That also follows the selection rules. That means this transition is also allowed. Third one, it has Mj 0, and here we have Mj plus 1. So Mj 0 minus Mj 1, delta Mj comes out to be 0 minus 1 minus 1. So again this transition is allowed. Similarly, we can easily check it out. The transitions shown by these black lines and these green line are also allowed transitions. So these are given by, these are shown by these lines. So this is the Zeeman pattern for the transition T21 to P11. I hope in the examination, if you got the question based upon the Zeeman effect or the Zeeman pattern, or to draw the Zeeman pattern, I think you can easily solve this question and attempt with full mark and get full mark.